Hello! Welcome to today's lesson on solenoids and their magnetic fields. We will start today's lesson by learning about solenoids and what they are. Next, we will learn about the magnetic field patterns around a solenoid, which resembles that of a bar magnet. Finally, we will explore methods to increase the magnetic field strength of a solenoid. So far, we have delved into the fundamental characteristics of magnets and the concept of magnetic field lines. You have also understood the magnetic fields produced by a current-carrying wire. Building on this foundation, we can now introduce the concept of solenoids. Let's get started. To begin with, let's clarify what a solenoid is. A solenoid is essentially a long coil of wire wound in the shape of a helix. When an electric current flows through this coiled wire, it generates a magnetic field, like a bar magnet. The unique helix shape of the solenoid is crucial because it significantly increases the strength of the magnetic field produced by the current flowing through the wire. How does this happen? Well, by winding the wire into a coil, the magnetic fields produced by individual turns of wire align and reinforce each other, resulting in a stronger combined magnetic field. This property of producing strong magnetic fields makes solenoids integral components in many electrical and electronic applications. Now, let's visualize the magnetic field pattern of a solenoid. Outside the solenoid, the magnetic field lines spread out and loop from one end of the solenoid to the other, creating a pattern similar to that of a bar magnet. These field lines exit from the North Pole and enter at the South Pole of the solenoid. This external magnetic field is weaker and more spread out compared to the field inside the solenoid. Inside the solenoid, the magnetic field is strong and uniform, highlighted by the parallel field lines. This makes the internal region of the solenoid a highly efficient space for magnetic induction, which is why solenoids are often used in inductors and electromagnets. We'll expand on these ideas in subsequent lessons. There are several effective methods to increase the magnetic field strength of a solenoid. One is to increase the current flowing through the wire. A higher current will produce a stronger magnetic field. Another method is to increase the number of turns in the coil. Adding more turns of wire makes the magnetic field denser, as more turns contribute to the generation of the magnetic field. Essentially, doubling the number of turns doubles the strength of the magnetic field. Relatedly, making the coils more compact can also increase the magnetic field strength. When the coils are closer together, the magnetic fields from each turn are more likely to align perfectly and reinforce each other, leading to a stronger combined field. Placing a soft iron core within the solenoid can greatly amplify the magnetic field strength. The soft iron core becomes magnetized and adds to the magnetic field produced by the solenoid, which significantly enhances the overall field strength. In today's lesson, we delved into the concept of solenoids and their magnetic fields within electromagnetism. We began by defining a solenoid as a long coil of wire wound in a helix shape that generates a magnetic field like a bar magnet when an electric current flows through it. We learned that the coil shape amplifies the magnetic field strength because the fields from individual wire turns align and reinforce each other. We then explored the magnetic field patterns of a solenoid, noting that fields outside the solenoid resemble a bar magnet's pattern, while the internal field is strong and uniform. Lastly, we discussed ways to increase the magnetic field strength of a solenoid, such as increasing the current, adding more turns to the coil, using a soft iron core, and coiling the wire tightly. In summary, understanding solenoids enhances our knowledge of creating strong magnetic fields for use in various electrical and electronic applications. Watch the rest of the GCSE physics course at Sophos Education.